Alright guys, welcome back. We are still in 10.2 where we're doing the washer method to find the volume, except these problems are being rotated about an axis that has been shifted. So we already did example 1, so here where it was being rotated horizontally, okay, like we see right here. This one is going to be rotated vertically, so please remember, when you see that you are rotating something vertically, okay, this is a vertical rotation, that means we use, everything has to be in terms of y. So that means we're eventually going to have to change these equations so they're in terms of y, and when we get our lower and upper limit, we're going to have to make sure that those are y values as well. So the lowest y and the highest y of our shaded area. Okay, so first let's go ahead and graph this. Okay, we should be familiar with these graphs because we've already looked at them once. So draw myself a little graph. Okay, x squared, that looks like this. Okay, the square root of x, that one's going to look like this. Okay, I know that these are going to intersect at 1, 1. Okay, so this is the area that we're looking at, and this time we are going to rotate it about the axis x equals 2. So here's my x-axis. Let me draw this out a little bit farther so I can put a 2 here. I'm going to rotate it, so I'll draw this one a little bit thicker so you see this is where we're rotating it about. I'm going to rotate it about this axis right here. So that means eventually we're going to get a piece all the way over here that looks something like this, and it's going to give us this three-dimensional shape here. Okay, it's going to look, I don't know if you ever played soccer, they put those little orange cones out. They're not full cones, but they're really flat to the ground, and people do practice around them and stuff. They're dribbling practice. So this is kind of what this looks like. So we got a little section of the thickness, and it's going to go all the way around, but there's going to be a big old hole in the middle. Okay, so that's the volume that we want to find for that shape. Alright, so now that we've got the graph drawn, I need to change these equations. So that's the first thing that I'm going to do here. Change equations. That just means I'm going to take both of these equations and I'm going to solve them for x so that they are in terms of y. So let's do the first one. So y equals x squared. To get the x alone, we square root both sides. So x equals the square root of y. Now, usually we would put a plus and a minus here, but because we're only using the positive side of this, where this shaded area is, I'm only going to use the positive here. Okay, so just so a reminder, this was the x squared, so that's this function right here. So I'm just going to call this a little 1, and I'm going to put a little 1 here, just so we don't get confused with which one's which. My other equation says y equals the square root of x. To undo a square root, we square both sides, so this gives us x equals y squared. Okay, so I'm going to call this little 2, this was the square root of x, so that means that's this piece right here. Alright, so this was my function that I'm calling 2. And I'm just doing that just so when we start looking at the outer radius and the inner radius, I remember which function goes with which piece. Alright, so that's the part that we're going to get to now. So I'm going to use a blue pen. This is going to be, I'm going to call it r of y, because remember we're in terms of y now. So this is to the outer function. So where we're rotating, which is this vertical line, to the outermost function. So the outer curve. So that's this one all the way here. So you see we're going to this too. So this is the function we need to be using. Okay, so be very careful. Okay, y squared, that function is actually the distance from the axis to the curve. So that's actually all this stuff on this side. if I want this other piece, I need to know the whole distance, which is 2, and we're going to take away this piece that we don't need, which is y squared. Okay, that will just leave us with this piece that's left right here. Okay, so that's going to be r of y, capital R of y. Okay, now I'm going to go to pink. So little r of y, so this is to the inner function, the inner curve. So from the axis that we're rotating to the inner curve, so that piece. So this here is going to be our little r of y. Well, I don't know that piece yet, but we do know that from our y-axis to this function, it is the square root of y, because remember that's that function right here was the square root of y. So this distance here is the square root of y. So I can take this whole distance of 2 and subtract my square root of y. Oh, sorry, I used my pink pen. 2 minus the square root of y. Oops, I say square root of y and I write the square root, or the square. Sorry guys. Okay, so now I have my outer radius and my inner radius. So now all we have to do is plug it in. So the volume is going to equal pi times the integral. So remember, when we fill in the lower and the upper limit of the integral, I need to use the smallest y value here and the biggest y value of my shaded area. So the smallest y here is 0. Then here the y value is a 1. So my biggest y is a 1. Now we're just going to plug everything in. So my capital R, so my outer radius is 2 minus y squared, and that all gets squared. Then I'm going to subtract my inner radius, which is 2 minus the square root of y, and all that is squared, and this is in terms of dy. Okay? When we type this into our calculator, we are going to get that this is approximately, when we make it a decimal, 3.246. Okay? Now, there are 4 problems on the practice. Please practice them. Each one of them is a little bit different. You're going to want to make sure that you pay attention to what pieces you actually should be subtracting, or if you should be adding pieces together. Okay, so make sure that you're really trying to find the distance from the axis to the curve that you're looking at. So think back to, I know it's hard to go from calculus back to like elementary distance, but please make sure you're paying attention to that and check your work with my key. Talk to you later.